Sai Ram. Now we have reached the last session of triangles from 9th standard mathematics. So in this last session we will see that how if an unequal sides are there, what we have to compare. Okay, till now in the last 3 sessions we saw that if two sides are equal, if two angles are equal, congruent, congruency, SAS, everything we saw. But if only equals are there, unequals are not there, yes, if unequals are there, what we have to compare, what will be our result, that is what we are going to see in this session. Okay, so the heading is inequalities in a triangles. Okay, let us see. I gave an assignment in the session 3. I think most of you have tried. Let us see how it came, and then we will go to the session. So our topics will be today our assignment first, then introduction, then 2 or 3 theorems on the basis of inequality, and solvables, which is very easy to solve. Let us move on to the assignment. So in this assignment what they have told, triangle ABC and triangle DBC are isosceles triangle. So first underline you have to put here, isosceles. Okay, then they both are on the same base. So base means a side should be common. Which is common here? BC, BC. So put underline there also. Then our vertices A and D are on the same side. They are telling B and A and D are on the same side, because A can be here, BC can be here, D can be here. Yes, it's possible, right? That is why they have given this line that A and D not in the other side, they are in the same side. But that also same side means D is above A or below A. That is also a big question. So that is how, why they have given that diagram. Okay, so they have given a diagram that ABC is a triangle, not a normal triangle, it is an isosceles triangle. Then DBC is a isosceles triangle, and A and D are on the same sides. AD is extended, AD is extended to BC to reach a point P. Then we have to show all these things. What and all we have to show? First one, ABD congruent to ACD. So let us see. Triangle ABD congruent to triangle ACD. So what is that? ABD congruent to ACD. Okay, now already they have given that both the triangles are isosceles triangles. Isosceles triangles means is in triangle ABC, AB is equal to AC, right? In triangle ABC, AB is equal to AC. In triangle DBC, BD is equal to CD, right? Now I am going to take the triangles ABD and ACD. I am going to take the triangles in triangle ABD and triangle ACD. I don't even have to look at here. Just by looking at the figure itself I can tell AB is equal to AC. Then BD is equal to DC. And a common person is there. Who is that? AD, which is standing common. So AD is equal to AD. So by SSS congruency, I can tell that ABD is congruent to ACD. I think you understood this. By from this, what I can tell, my other angles are equal, I can tell. Yes. So on the basis of the first, I am telling what I need is angle BAD is equal to angle CAD. That means if this is X, this is also X. We have seen this somewhere, where when a line is dropped from an angle and it is dividing in equally, then that line is called bisector line. Correct? So AD is not a normal line, it is a bisector line. Okay. From this we came to know that AD is not a normal line, it is a bisector line. Now let us see the next one. ABP, that means ABP congruent to ACP, that is what I have to prove. Okay. Now in triangle ABP and triangle ACP, what I have? AB is equal to AC. AB is equal to AC. Okay. Next, AP is equal to AP. Common standing there. Right. Next, in the previous proof, what I have proved? Angle BAP is equal to CAP. How? Here you have written BAD and you are telling BAP. In the previous session what we told? The angle never depends upon the length of the arm. Correct? The angle never depends on the length of the arm. So what we get? BAD can be written as BAP and CAD can be written as CAP. Correct? So on the basis of that, BAP is equal to angle CAP by side angle side. Side angle side congruency, I can tell that both the triangles are congruent. Right? In that, what I can tell? Other things are there. What are all things I left? Because it is an isosceles triangle, already B and C are all equal. Angles that are equal, already one more angle is there. That also I told equal in from the first. So all the angles are equal. I don't have to care about the angle, but I have to care about the side. BP is equal to PC. So from this I got BP is equal to PC. Right. BP is equal to PC. That is what I got from the other proof. Okay. So next one. Let us write once again. Angle BAP is equal to angle CAP from the first, and here BP is equal to PC. This is what I got from the second. The third, what I have to prove? AP bisects angle A. Yes, just now we got that these two angles are equal. Yes, it is a bisector, but we have to tell that the line bisects D also. That is what we have to prove. For that, what we are going to take? Triangle BDP and triangle CDP. Okay, since BDC is an isosceles triangle, we have BD is equal to CD already. Okay, then in the previous proof we have BP is equal to PC, right? BP is equal to PC. So the common person standing there, who is that? DP. DP is common. So by side congruency, I can tell that BDP and triangle CDP are congruent, right? So by this, what I am going to tell? What I need? I have talked about all the three sides. Now I have to talk about the angles. These two angles are equal. All the other angles are equal. That means if from the first we have told this is X, means that side also X. From here, if this is Y, means this is also Y. When I will get that position? If the line which is starting and passing through divides equal means it should be a bisector. That is what I have given here. Okay, next one. So third one over. Fourth one, AP is a perpendicular bisector of BC. AP is a perpendicular bisector of BC. So what is the mean by perpendicular bisector? If I am reaching from a vertex to the another point in such a way that I am dividing perpendicularly, means I have to show that this is also 90, this is also 90. That is for perpendicular. Bisector means BP should be equal to PC. That I have already proved, right? BP is equal to PC, I have already proved, and just I have to tell that this is 90, 90. We have showed that AP bisects D also and A also. Okay. Next. So last one, we have to prove that BP is equal to CP and APB is equal to APC is equal to 90 degrees. That is the biggest one that easily we can prove. So BP is equal to PC we have already proved from the second, right? D, P, B, C. BP is equal to PC we have already proved from the second. Then what it will tell? Since BC is a line, we can tell that if I add these two, I must get 180 degree. Is it right? BC is a straight line. So if I add the corresponding angles, that means next angles, if I add these two, I should get 180 degrees, right? Since I have proved previously that BDP is congruent to CDP and both these angles are equal by CPCT. That means if it is X, this is also X. And now only we told that if I add these two, I must get 180. So X plus X is equal to 180. So 2X is equal to 180. It leads to X is equal to 90. I have reached the perpendicular, right? So that's all we have to prove. We have already proved that it's bisector, and now we proved that it is a 90 degree also. Okay. So we finished our assignment. So that is our homework. Now let us start our session here. So in this session what we are going to tell is, if some unequal sides or unequal measures are there, what is the result will be in that triangle? That is what we are going to see here. So we have been mainly studying the equality of sides and angles of the triangle or triangles. Till now what we are seeing? Equality of the sides and angles. Sometimes we do come across unequal objects, but we cannot tell that, oh, it is unequal, I will not take this consider as a triangle. We have to take and we have to compare something in that. We need to compare them also. Like example, line segment AB and CD. AB, CD. In this I can tell that AB is greater than CD. Right? Next. Angle A is greater than angle B. Angle A is greater than angle B. So if I combine this both, what I get? A line and also the angle difference. So in this, AC is lesser than A dash C. AC is less than A dash C. A dash C is less than A double dash C. Okay. Next, let us move on to the angle. Angle ABC is less than A dash BC, which is less than A double dash BC. Right? Here what we are seeing, when the length is increasing, my angle is also increasing. Just now you told that my angle never depends on the length of the arm. Carefully see that. Length increases when opposite angle increases. We are not talking about the included angle. We are talking about the opposite angle and sides. So please be careful when you are studying each and every word, because just one word changes whole problem, whole sums will be changed. So what here they are telling? The length increase. If the length increase, then its opposite angle will increase. That is what we are going to see here. Okay, I think you understand this. It's a very important concept. Keep that in mind. So let us see the next. And this is, I think you have heard this, but this will be very helpful to solve in this session. Exterior angle theorem. What is meant by exterior angle theorem? If there is a triangle, if I extend one side, I will get one exterior angle, right? That exterior angle have a relation with the interior angles also. So what is that? The exterior angle of a triangle is equal to the sum of opposite two interior angles. The exterior angle of a triangle is equal to the sum of two opposite interior angles. Okay, if this is the exterior angle, opposite two is here. If I'm talking about here, means these two are the opposite. Okay, so keep that in mind. We are going to use in our theorems and solvables. So let's see the first theorem. In this session, all the theorems will be very easy only, and just this is bigger, so this is smaller, so this is bigger. So bigger, smaller, larger, longer will be coming. So don't get confused. Just look at the figure and just concentrate on the figure. Don't concentrate on the words. If two sides of a triangle, till now we are comparing two triangles, but now we are going to compare the sides of a triangle. If two sides of a triangle are unequal, the angle opposite to larger side is larger. What is that? Larger side is larger. If two sides of a triangle are unequal, the angle opposite to the larger side is larger. Now you understand? If two sides of a triangle are unequal, then the angle opposite to the larger side is larger. That means AB is the larger side. Larger side's opposite is C. So C is the largest angle. That is what they are telling here. So let us see how it is. ABC is a triangle such that AB is greater than AC. Since here they have given only one triangle, I cannot compare here and all. So what I have to do? I have to construct one triangle inside that only, not outside that. So I am taking a point P on AB such that my AP should be equal to AC. I am taking a P point on AB such that my AP should be equal to AC. Now it leads to the isosceles triangle. So my opposite angles will be equal. If this is X, this will be X. Right? Okay. I got X. Next, look at my two new triangles. I have two triangles now here. Now I can compare with the SAS, like that. Now, if I mark this as Y, here it will be X plus Y. Then here Y will come? No. Since it is a straight line, I will get this as 180 minus X. Let us see. This is my new triangle. I am taking a point P on AB such that AP is equal to AC. So I have two equal angles, X and X, and I have marked the another angle as Y. So my proof goes like this. So this is a bigger, little bit easy to write. Here AP is equal to AC, so X is equal to X, angle is equal. Next on the line AB, this is X means then this will be 180 minus X. Okay, now I forget about my APC triangle. Let me see about this small triangle. Okay, so who are all there? B, P, C, right? I have B, P, C. In BPC, B, P, C, first one, plus next BPC, next PCB, PCB, plus CBP, CBP should be equal to what? Sum of the angles of the triangle is 180, right? So now I will apply whatever I know. So BPC I have 180 minus X, PCB I have Y. I don't know about CBP, so I'm keeping that as it is. I can write B itself, right? Okay, is equal to 180. Keep the known one side, unknown other sides. So what I will get? CBP is equal to 180 minus 180 minus X becomes plus X, plus Y becomes minus Y. It reaches CBP is equal to X minus Y. That means this angle is equal to X minus Y. Okay, so that is the proof here we have. You can see it. BPC is equal to X minus Y. Now, normal thing, 3 plus 2 will always be greater than 3 minus 2. Is it right? And it will be greater than any one of this also. Do you agree with me? I'm telling 3 plus 2 is greater than 3 minus 2. And 3 plus 2 is greater than any one of them, 3. And 3 plus 2 is greater than 2. Do you agree with me? The same concept we are going to use here. See, now angle C is equal to X plus Y. Angle B is equal to X minus Y. So angle C is equal to X plus Y. Angle B is equal to X minus Y. 3 plus 2 is greater than 3 minus 2. So X plus Y is greater than X minus Y. Right? So who is X plus Y and who is X minus Y here? X plus Y is the angle who is opposite to the larger side. Correct? Next, B, which is opposite to the smaller side. Is it right? So that is what we have to prove. If I have unequal sides, my largest side angle, opposite angle will be larger. So we have here angle C is greater than angle B. Similarly, I can, since I have taken here, just I have compared these two. Then I can compare AB and CB also. Right? That it's on you. You do that proof. So by this we proved that if a larger side and a smaller side is compared, then the angle opposite to the larger side always larger. Okay? Hence we proved this theorem. Theorem 7. Next one. So this is very easy. If you get this theorem, please write it. You will get 3 marks or 4 marks easily. In any triangle, the side opposite to the larger angle is larger. Just ulta of the previous theorem. Previous theorem what they told? Larger side, larger angle. Now they are telling larger angle means it should be opposite to larger side. So let us see what they are telling. If C is the larger angle, then AB should be the longer side. So given ABC is a triangle and they have given C is greater than angle B. C is the largest angle, so I can compare with both B or A. It's not a big thing. Next, to prove, what I have to prove? AB is greater than AC. Okay. To prove that AB is greater than AC, I assume that AB is smaller than AC. Let me assume that AB is smaller than AC. If AB is smaller than AC means, what will it reach? AC's opposite is B. Correct? As per the previous theorem, the larger side will have opposite angle larger and AB's opposite is C. Angle B should be greater than angle C. Is it true? No, it's false. So my assumption is false. Easily I can tell that yes, AB is longer. So easy, it's very easy. Just which contradicts my assumption. I have assumed that AC is greater than AB. I have reached that angle B is greater than AC. That is wrong. So my assumption is wrong. That is why AB is greater than AC. So hence proved. This is very easy one. Next. The sum of any two sides of a triangle is greater than the third side. Now all these theorems concentrate on a single triangle. So what they are telling, till now we are concentrating on the side and angle side. Now this theorem concentrates on the sides. The sum of any two sides of the triangle is greater than the third side. That means if I add AB plus AC should be greater than BC. That is what we have to prove here. So given a triangle ABC, I have to prove AB plus AC is greater than BC. So what I am going to do? Construction. Why? Because I don't have anyone to help me there. So I have to help myself. So I construct AB to D. What I am going to do? Just I am extending A to D in such a way that AC is equal to AD. That's all. AD is equal to AC. So my new diagram will be looking like that. Here you have to see these two sides are equal. So my brain immediately should tell that angles also equal, because that is an isosceles triangle. So let us see the proof. Since in ACD, since I have constructed that in the same way so that it should look like an isosceles triangle, in triangle ACD, AC is equal to AD. So angle 1 is equal to angle 2, right? Now I have joined all these things. This is the one I have named one. This one I didn't give the name. So I am writing BCD is equal to BCA plus 1. That means I am adding this both the angles. That's all. Nothing more than that. Okay. Now angle 1 is equal to angle 2. That means 3 is equal to 3. Now I am giving a 5 or any number to one side. I am adding 5 plus 3. Now also can I write that both are equal? Not possible. I have to write 5 plus 3 is greater than 3. Right? The same thing I am going to do here. For 1, I am giving one extra angle, that is BCA. I am giving one extra angle BCA so that it becomes BCA plus 1 is greater than 2. Greater than 1. 1 is equal to 2. So BCA plus 1, instead of 1 I am writing as 2. Same thing, 5 plus 3. 3 is equal to 3. 5 plus 3 is always greater than 3. BCA plus 2 is always greater than angle 2. Okay. Next, in BCD, now I am going to enlarge my triangle. In triangle BCD, this angle is greater than 2. Just now I proved. Right. So now I have reached somewhere. One angle is bigger and one angle is smaller. That means I can compare with the opposite side. The larger angle have longer side. Smaller angle will have smaller side. Right. That means these two is opposite to AD. That means BCD greater than 2. This leads to BD greater than BC. But who is that BD? AB plus AD, right? Who is that BD? AB plus AD is equal to BD, right? Now BD is greater than BC. Now who is that AD? Already that is my construction. So I can write AB plus AC. I don't want this. Directly I will write as greater than BC. That's all, I reached my destination. See, AB plus AD is AD I can interchange as AC. So I have reached the position that if the sum of the two sides is greater than third side in a triangle, sum of the two sides will be greater than third side. Okay, I think you understood all the theorems. Really, the theorems are very easy. Just concentrate on the figures, not on the words. Now let us see the solvable. It's very easy. All the solvables are, because the concept is very easy. In the figure, angle B is greater than angle A and angle C is less than angle D. Show that AB less than BC. See here, angle B less than angle A. That means angle A is larger. So OB should be greater. Simple. Angle A opposite to who? OB. Angle B opposite to who? OA. Next, angle C. Angle C is opposite to who? OD. Angle D is opposite to OC. Just add the right hand side, add the left hand side. You will get the answer easily. In AOB, B is less than A. So AO, B is opposite, AO is less than BO by the theorem. Next, in triangle COD, C is less than D. C is opposite to OD. So OD is less than OC by the theorem. Just add the right hand side of both. We will get OA plus OD is less than BO plus BC. Who is that AO plus OD? AD. And BO plus OC? BC. This is what we have to prove. It is very easy. Just we have to think that, we have to keep that in mind, that larger angle's opposite side is longer. See, AD is less than BC, hence we proved. Next, solvable second sum. In the given figure, PR greater than PQ and PS bisects QPR. QPR. So here PS bisects, that means two angles are equal. We have to prove PSR is greater than PSQ. That means PSR is greater than PSQ. Okay. Here one angle is another side, one angle is this side. How to compare that? That means I have to break that triangle PQR in two. Okay. So what I am going to do? I have to take two triangles PQS and PSR. In that first, let us write what is given. PR is greater than PQ. So my theorem will tell that if PR is greater than PQ, who is greater? Q will be greater. Right? Q is greater than R as per my theorem. So next, what they have wrote? PS is a bisector of QPR. They have given the question itself that this is X and X. So QPS should be equal to RPS. Okay. Next, in triangle PQS. In triangle PQS. Who is the exterior angle? PSR is the exterior angle. Why we have to take PSR? Because in the question they have asked about PSR, right? So PSR is a exterior angle. So PSR is a exterior angle means exterior angle and the interior angle have a connection. What is that? PSR is equal to PQS plus X. Right? Exterior angle PSR is equal to PQS plus X. And here you have written as S. Here you have written as R. How? Why? You have to tell the answer. Why? Because the angle never depend on the length of the arm. QS, QR are same line. So have interchanged the S as R. That's all. So the next. Now they have given that PR is greater than PQ. So that is why Q angle will be greater than R angle. Right? So if I am adding a X with that greater angle, if I am adding a X with this greater angle, then what will happen? They have told Q is greater than R. Right? Angle Q is greater than angle R. And I am adding X on both sides. Then also it is greater. Is it right or not? Is it right or not? Just an example. 8 is greater than 5. I am adding 2 to both. So it becomes 10 greater than 7. Is it right or not? The same theory here also. So PQR, Q angle is greater than R angle. I am adding X on both sides. It will reach that PQR is equal to PSR, which is greater than PSQ. That is my destination where I have to reach. It looks like little bit this big, that big and all. But if you very confident with your theorem, it's very, very easy to prove each and everything. Just please concentrate on the figures, not on the words. By this, we finish our triangle chapter. So now I'm not going to give any assignment because since we finished the chapter, you have to do other sums which we didn't covered. Okay? Thank you. I think you understood this chapter. Thank you. Sai Ram.